Hey everybody, so this is the key for homework 10.7, the color of things. I'm going to try and get these keys out a lot quicker, really the day after. So here we go. First off, number one, what are the colors of our spectrum, Mr. Ager spectrum? Again, I just want to give nice, crisp, clean things. This isn't exactly right. They are a little bit different, but I just think it works better with these numbers and these words that kind of come together. So, red, 700, orange, 650, yellow comes after orange at 600 nanometers, green at 550, cyan at 500, blue at 450 nanometers, and violet at 400 nanometers. Number two, you look at a blue LED light. So I'm looking at a blue light. What color would my brain think that it sees? Well, my brain would think that it sees blue. This A should be pretty straightforward. Like your brain thinks it's the thing we've called it. But then extend that and like why? Why does it think that? So what cones are activated in your eye to see this color? It would be the blue cone. All right, so let's go extend it a little bit. You look at a yellow stoplight and decide to put on the brakes. What color does your brain think it sees? It thinks it sees yellow light. What cones in your eye are being activated? Well, to get yellow, you're activating your red and your green cones. That yellow frequency light is activating both the red and the green cones. Number four, you look at the sun. Yep, right at it. What color does your brain think it sees? I was going for white here. I know I talk a little bit about yellow, and then today's video was all about how it's yellow light. A little yellowish, but white's what we're going for. White is all the colors. What cones are activated when you glance at the sun? All of them. Red, green, and blue cones. Number five, you look at a light, and for some reason, you know that it's activated the blue and green cones in your eye. What color is your brain thinking that it's seeing? Your brain, if it's activated blue and green, thinks it's seeing cyan. All right. And finally, later in the day, you look at the sun. It's about to set. The blue, cyan, and green has been scattered out. So if I've scattered out the violet, blue, cyan, and green, all those, I'm left with just red, orange, yellow. So what color does it think I see? You see orange. Maybe a red, yellow, orange kind of combination there. So you see orange. 7. It's the next day, and you look at all the green leaves. So we're looking at a green leaf. What color do you think you see? You think you see green. So now we're looking at the object, not the source of light, but objects. So what color or colors of light are absorbed by the leaves? Well, I'm going for all the colors except green. So red, orange, yellow, cyan, blue, and violet. What color of light, colors of light is reflected by the leaves? Green. That's why you see green light. You now look at a violet flower. What color would your brain think the flower is? Well, thinks it's violet. What colors of light are absorbed by the flower? Well, all of them but violet. Red, orange, yellow, green, cyan, and blue are all absorbed. What colors of light are reflected by the flower? Violet. All right, you look at a black car. Last two. You look at a black car. What color would your brain think the car is? Black. Okay. What color of light is, what color or colors are absorbed by the car? Well, to get black, you have to absorb all the colors, reflect nothing. So all of them are absorbed, and what colors are reflected? None of them. None of the colors are reflected. 10. You now look at a house. It's not absorbing any light. So we just look at it. We know, for some reason, we know that it's not absorbing any light. What color do we think that house is? Well, if we're not absorbing any light, that's all the light reflected, and so we call that white. Hope these are a little helpful.